Hello everyone, today we'll be presenting our final project unit design titled Pushes and Pulls. This unit is designed for kindergarten students and introduces them to the foundational concepts of force and motion. Go to the next slide.
Yeah, trying. Sorry. I'm not sure what's not letting me. There you go.
In this unit, students learn that a force is simply a push or a pull, and that different strengths or directions of these forces can change how objects move. Through hands-on exploration, they'll begin to see how these concepts apply in their everyday world. We chose this topic because pushes and pulls are highly engaging and age-appropriate for kindergartners. It allows students to explore science through play, something very natural for this age group, and helps them make real-world connections through observation and experimentation. Our class includes 18 students aged 5 to 6. 3 receive English learner support, 2 have IEPs, and 4 are in reading and math intervention. Since this group learns best through tactile and playful experiences, the unit is designed to be active, visual, and collaborative. The standards for this unit are from NGSS. Students will compare the effects of different strengths or directions of pushes and pulls, and then analyze data to determine whether a design solution works as intended to change speed or direction. Our learning objectives are measurable and aligned with the standards. By the end of this unit, students will be able to identify pushes and pulls, explain what happens when a weak or strong force is used, and finally apply their learning by designing a bulldozer that uses force to knock down cups. We used Brewer's Thinker Tools framework to guide this unit. This model emphasizes inquiry-based learning and helps students move through phases of motivation, experimentation, and application as they build understanding. The 4 phases are motivate, where students make predictions and get curious; model, where they experiment based on their own experiences.
Sorry.
Okay. The 3rd phase is formalization, where they test and record results; and transfer, where they apply their learning to real-world tasks. Each day of our unit aligns with one of these phases. We will be using mainly 2 types of technology for our project. The first is the PhET simulation. It represents forces and motion basics. It allows students to manipulate variables and observe force effects. And we will be using a Mystery Science What's the Biggest Excavator, which is an interactive lesson linking classroom learning to real-world applications.
All right, and now we are going to go over to our day-to-day lesson for the learning experience of the students. So on day 1, we're going to go to the motivate phase of Brewer's Thinker Tools. On the first day, students are introduced to the concept of force, and students are asked to predict what causes objects to move and brainstorm ways they move objects in their daily lives. This sets the stage for curiosity and inquiry. And then for day 2, students use the PhET forces and motion simulation. They experiment with pushing and pulling to move objects on the screen. They observe how changing the strength or direction of a force changes motion. It is a digital way to model what they'll explore later on. And then on day 3, students work in groups to build a maze for a ping pong ball using squishers to push it through. They reflect using sentence stems like, when I use a weak force, and a force can change direction too. This helps them formalize their understanding with language and observation. And then on day 4, students engage with a mystery science lesson called What's the Biggest Excavator? It ties their classroom experiments to real world engineering and shows how pushes and pulls power big machines. And then on day 5, students apply their learning in a creative engineering challenge, designing and building a bulldozer that can knock down cups using a push or pull force. This performance task lets demonstrate mastery of both scientific understanding and design skills. And that also is the last phase of Brewer's Thinker Tools, which is transfer. And this is our differentiation plan. So our differentiation plan ensures that every student is supported and challenged appropriately. Students are grouped by performance levels, and instruction is scaffolded with teacher and peer support. High-performing students have opportunities for independent problem solving. And here are some examples of what student artifacts might look like, from their maze designs to their final bulldozer projects. These artifacts reflect both creativity and scientific thinking. And then for some of our assessments of learning throughout the unit, assessment occurs throughout the unit using informal methods like thumbs up, thumbs down, and class discussions, as well as final performance assessments where students test their bulldozers. So this assessment of learning throughout our learning give us an insight into both conceptual understanding and application. So the thumbs up and thumbs down will be an end of the lesson assessment. So the teacher will ask a yes and no question, and students will answer using their thumbs to answer the question. And same with class discussions. Teacher will listen to student responses and take notes of which students are understanding the concepts and which students need more support. And then for our final assessment, which is like our end of unit assessment, there is a rubric that shows whether the student is meeting, progressing, or beginning the for the concept of our pushes and pull unit. So thank you for listening. This unit blends hands-on science, play, and inquiry to help young learners understand the forces that shape their world. We'd be happy to answer any questions if you have any. You can just type it on the comment section. And these are our references. Thank you.